Okay, so now we want to find the corresponding y value for this point of inflection, and we need to verify that it is an actual point of inflection by looking at the concavity on either side of this value for x. So let's first of all, when x equals 2, what's y going to equal? We substitute 2 back into our original function, so we end up with 2e to the negative 2, or in other words, 2 over e squared. Okay, so we have a possible point of inflection, at 2 and 2 on e squared. Let's verify it is a point of inflection by looking at our table and the second derivative. So when x equals 2, we're going to take something to the left, like when x equals 1, and something to the right, like when x equals 3. So substituting x equals 1 into our second derivative, when x is 1, we've got e to the negative 1 times 1 minus 2, which is negative 1. So that gives us a negative result here. And if the second derivative is negative, that means we've got a concave down function to the left of 2. Now let's look to the right of it. So for example, at x equals 3. When we look at x equals 3 and we substitute in here, we end up with, remember this at 2 gives us a result of 0, e to the negative 3 times 3 minus 2, which is 1. And that's going to give us a positive result. So there is a change in concavity, hence there is a point of inflection. So change in concavity. So that's verified that the point of inflection is at 2 and 2 on e squared. Now let's put all that information together and see if we can come up with a sketch. Now let's go back through each of these steps. So we know it's going to cover all values for x. We know it's not odd or even, so it's not going to be symmetrical around the y-axis. It's not going to have rotational symmetry. We know that it goes through here at 0, and we know to the left of 0 the function is negative, so from here it's going to come down, and we know to the right of 0 from our table of signs it's positive, so it's going to go up. We also know as x is approaching infinity in a positive direction, our function's actually going to get close to 0. So this is going to become an asymptote. So we have an asymptote at y equals 0. In other words, our x-axis, as we go in this direction, in a positive infinite direction, we know that it's going to get closer to 0. And we know when x is negative, as these values for x go further into the negative direction, we know that it's going to approach negative infinity. So it's going to come down here quite steeply. We've got a stationary point at x equals 1. So at x equals 1, we've got a stationary point, and the coordinate of that stationary point is 1 and 1 on e. And then we have at x equals 2, we've got a point of inflection. So somewhere around here at 2, 2 and 2 on e squared, we have a point of inflection. So there's a change in concavity. So let's put all that together. We know that this has to be a maximum, like this. We know as it was coming down in the negative direction for infinity, it was getting increasingly larger. And we knew that there had to be a change in concavity here, so it had to go from being concave down to concave up. So it's a change in concavity. Here's our point of inflection. And we also knew as x was approaching positive infinity, then our function was approaching 0, because we've got an asymptote along the x-axis.